This is part 2 of lesson 11.9. In this lesson, we will do some examples using the normal distribution. So in this example, we have a population of male European eels, and you can see in the picture that they've given us the mean and one standard deviation above the mean and one standard deviation below the mean. What they're asking us to do is draw a normal curve and label 1, 2, and 3 standard deviations from the mean. So, draw our normal curve here. The mean would go in the middle, and then one standard deviation we know is 18.5. So now to get the next standard deviation, we have to figure out the distance between the mean and the first standard deviation. So 18.5 minus 15.7 gives us 2.8. So what we know is one standard deviation is 2.8. So if we add 2.8 to 18.5, we would get 21.3. Adding another 2.8 would give us 24.1. Going the other way, they tell us that one standard deviation smaller is 12.9. And since one standard deviation is 2.8, then we know that two standard deviations would be 12.9 minus 2.8, so we'd be at 10.1. And three standard deviations would put us at 7.3. So there we have a normal curve. In our next example, we're talking about adult American males. And it says that the heights of adult American males are approximately normally distributed with a mean of 69.5 and a standard deviation of 2.5. They want us to calculate a percent, which means we're going to have to draw our picture and label the percentages. So in the middle, we have 69.5, and then going 1, 2, and 3 standard deviations in each direction would give us, one standard deviation puts us at 72 inches, add 2.5 to that, we're at 74.5, and adding 2.5 to that, okay, so if we add 2.5 each time, we will get these numbers, and our third standard deviation is 77 inches. Then going back to the mean and subtracting 2.5, we would get 67 and 64.5 and 62. Okay, that still doesn't tell us the percentages, so what we're going to need to calculate the percentages, we're going to have to put in the values that we know from before. So let me shade first. We want to know between 67 and 74, so we want to know this region. So we know one standard deviation to the left is 34%, one to the right is 34%, and the second one to the right is 13.5%. So if we add these all up, we get 81.5%. So 81.5% of adult American males are between 67 and 74.5 inches tall. So next question, in a group of 2,000 adult American males, about how many would you expect to be taller than 6 feet? So we're talking about this region. So to do this one, we're going to kind of work backwards here. Anything to the left of the mean, if we add up everything on the left, that should be 50% of our data values. And one standard deviation to the right is 34%. So left of 72 inches is 84%. So if we want to know to the right of 72, it would be 100% minus the 84% on the left, which still leaves us 16% on the right. So if we have 2,000 adult American males and 16% of them are taller than 6 feet, that would mean we would have 2,000 times 0.16, which gives us 320 men should be above 6 feet tall in a group of 2,000. That's it for lesson 11.9.